today we are going to discuss about the next cycle, Bell-Coleman cycle. Next type of cycle, that is Bell-Coleman cycle. Coleman cycle. This is another type of air refrigeration cycle. This is next type of air refrigeration cycle in which air is used as a working substance. In the last class we are discussing about reverse Carnot cycle. This is one type of air refrigeration cycle. Next one, this is Bell-Coleman cycle, और उसको बोल सकते हैं reverse Joule cycle और reverse Brayton cycle. This cycle is also known as reverse Brayton cycle or reverse Joule cycle. This is one of the air refrigeration cycle in which air is used as a working substance. Okay. So here also there is a PV diagram and PH diagram. This is known as the PV diagram, pressure versus volume diagram. Pressure versus volume diagram. Another one is this is known as temperature versus entropy diagram. Temperature versus entropy diagram. Two diagrams are more important. PV, pressure versus volume, and temperature versus entropy. In this cycle, there are two isentropic process and two isobaric process for constant pressure. So here in PV diagram, this is the PV diagram 1 to 2. This is one state 1. Here the state 1 pressure, volume, temperature. P1, V1, T1 and the pressure, volume and temperature. At the point 2 condition also the pressure, volume, temperature condition change to P2, V2, T2. This is point 3 state. This is point 4 state. Here in this case 1 to 2 this is known as isentropic compression process. Isentropic compression process. Isentropic compression process. And 2 to 3 this is another process. 2 to 3 isobaric or constant pressure. Constant pressure process, constant pressure process. Then 3 to 4 this is isentropic expansion process. Then 4 to 1 this is known as the constant pressure. So constant pressure, that is P1 is equals to P4, that is here in this case P2 is equals to P3. So 1, 2, 3, 4 is a pressure versus volume diagram. Similarly, we can draw the temperature versus entropy diagram. So temperature versus entropy diagram 1 to 2, isentropic compression. So 1 to 2, this is 1 condition, this is 2 condition. 1 to 2 isentropic compression. Then 2 to 3 constant pressure. 2 to 3 that's a constant pressure. 3 to 4 again isentropic process. Then 4 to 1 which is constant pressure process. This is the figure of pressure versus volume and temperature versus entropy. 1 to 2 isentropic compression. That is isentropic, isoentropic. That is S1 is equals to S2. So corresponding to 1 to temperature, this is known as the temperature T1. Corresponding to temperature T2, this is temperature T2. Corresponding to 3 state, this is T3. Corresponding to temperature 4, this is T4. 1 to 2 isentropic compression is there, and 2 to 3 that is constant pressure. 2 to 3 constant pressure. In this case there is no pressure is there, so this is decreases constant pressure. Then 3 to 4 isentropic expansion process. That is S3 is equals to S4. Then 4 to 1 this is known as a constant pressure cycle. So here in this cycle, Bell-Coleman cycle or reverse Brayton cycle or reverse Joule cycle, so there are two isentropic process. Here isentropic. But another two are known as the isobaric process. In a reverse Carnot cycle, there are two isothermal process and two isentropic process. Here these are the two isentropic process. But instead of in the Carnot cycle there are isothermal process. But here constant pressure or isobaric process. Okay. So here heat addition or heat rejection takes place in a constant pressure process. So now so here 1 to 2 isentropic compression, 2 to 3 constant pressure, 3 to 4 isentropic expansion, 4 to 1 constant pressure process. Same case previously. So here in this cycle, this is the cycle in which air is used as a working substance, which is one of the ancient type of refrigerator, where the persons are taking picture used in the ships, marine ships. or person carrying the cotton beads into the seeds. So here in this cycle there are two isentropic process and two constant pressure process. Here at the point 1 let pressure, volume and temperature P1, V1, T1 are the pressure, volume, temperature at the point 1. The condition at the air condition. So there are four stages are there. First stage or process 1 to 2 isentropic compression, stage 2 constant pressure isobaric process, stage 3 isentropic expansion process, stage 4 constant pressure process 4 to 1. So first of all the pressure during the isentropic compression process, pressure क्या होता है? Pressure increases from P1 to P2. Pressure increases from P1 to P2. Increase हो रहा है ऊपर जा रहा है ग्राफ से P1 से ये increase हो रहा है P1 से P2. Pressure increases from P1 to P2. Temperature क्या होता है? Temperature also increases from P1 to P2. Both pressure and temperature increases from P1 to P2 and temperature increases from P1 to P2. Then volume क्या हो रहा है? Volume decrease हो रहा है. तो ये देखो ये लाइन है V1 है, ये कॉरेस्पॉन्डिंग लाइन है V2 है, ये कॉरेस्पॉन्डिंग टू V4, ये कॉरेस्पॉन्डिंग टू V3. तो 1 to 2 क्या हो रहा है? V1 था ये V4 गया, इधर आ रहा है लेफ्ट साइड आ रहा है. दैट इज वॉल्यूम डिक्रीजेस. वॉल्यूम डिक्रीज हो रहा है, प्रेशर और टेम्परेचर दोनों का इंक्रीज हो रहा है. सिंस इट इज ए क्या प्रोसेस? कौन सा प्रोसेस? आइसेंट्रोपिक प्रोसेस. तो हीट ट्रांसफर ड्यूरिंग द प्रोसेस Q1 to 2 is equal to 0. That is the air neither receives heat nor gives out heat. Heat नहीं देना है, नहीं देना है. Heat transfer during the process is equal to 0. समझ में आ रहा है? Then second process, process 2 to 3, constant pressure process or isobaric process. Constant pressure or isobaric process. Here this process during the process 2 to 3 क्या हो रहा है? The P2 to P3 pressure constant. So during the process the temperature, the pressure of air remains constant. P2 is equal to P3. Pressure same होगा. Then temperature क्या हो रहा है? During the process temperature also temperature decreases from P2 to P3. And volume क्या हो रहा है? Specific volume of air also decreases from P2 to P3. तीनों basic parameter लिखना है. Pressure, volume, temperature. Pressure constant हो रहा है P2 equal to P3. Volume decrease आ रहा है V2 से V3. Temperature drops from T2 to T3. Okay. Since it is a constant pressure process, we know that during the constant pressure process Q2 to 3, the heat transfer during the process is equal to mCp dt. M equals to mass of the gas, Cp equals to specific heat at constant pressure, mCp into dt. Here a word is specific heat. What is specific heat? It is the amount of heat required to raise the temperature of a unit mass of gas through 1 degree. In a gases there are two types of specific heats are there. Specific heat at constant pressure Cp, specific heat at constant volume Cv. Cp and Cv. Specific heat at constant pressure, it is the amount of heat required to raise the temperature of a unit mass of gas through 1 degree when it is heated at constant pressure. Cp का वैल्यू कितना है यार? 1.005 kilojoule per kg Kelvin. Similarly, Cv, it is the amount of heat required to raise the temperature of a unit mass of gas through 1 degree when it is heated at constant volume. Cv का वैल्यू क्या है यार? 0.712. और we know that Cp minus Cv is equal to R and Cp by Cv is equal to gamma. Okay? समझ में आ रहा है? So during this process, constant pressure process, this is equal to mCp into dt. जब per kg ले जाएंगे 1 kg of air, so heat transfer during the process 2 to 3 is equal to Cp into dt. T2 minus T3 कौन सा ग्रेटर है? T2 ग्रेटर है, T3 स्मॉलर है. So नहीं है, T2 ग्रेटर, T3 स्मॉलर. So Cp into T2 minus T3 is the heat transfer during the process Q2 to 3 is equal to Cp into T2 minus T3. समझ में आ रहा है? नहीं आ रहा है किसी का? Okay. Next process T24 that is isentropic expansion process. Now the air is passed to the isentropic expander is there. 4 to 1, 3 to 4. There is expander is there. That is isentropic expansion process takes place. So during this process expansion होगा तो क्या हो जाएगा? Pressure drops हो जाएगा. Pressure drops from T3 to T4. Pressure decrease हो रहा है T3 to T4. Temperature decrease हो रहा है T3 to T4. And volume क्या हो जाएगा? Increase हो जाएगा. Volume increases from T3 to T4. Since it is a isentropic process, that is the air neither receives heat nor gives out heat. Heat transfer during the process is equal to 0. समझ में आ रहा है? Is equal to 0. Then another one, there is a 4 to 1 process. 4 to 1. After that, the air is passed to the 4 to 1. 4 to 1, there is a refrigerator there. So 4 to 1, the constant pressure process. तो प्रेशर रिमेंस कांस्टेंट T1 is equal to T4 4 to 1 but ये कांस्टेंट प्रेशर में क्या टेंपरेचर इंक्रीजेस फ्रॉम 4 to 1 दिस इज द लाइन डायग्राम ऑफ ए वेल कोलमैन साइकिल में लाइन डायग्राम 1 to 2 कंप्रेसर लगे जैसे कंप्रेसर इज देयर कंप्रेशन प्रेशर 1 to 2 2 to 3 कांस्टेंट प्रेशर में कूलिंग हो रहा है 2 to 3 दैट इज कूलर इज देयर सो हियर coolant in and coolant out so there is a cooler is there then again 3 to 4 expansion process is there is a expander is there 3 to 4 there is a expander is there expansion takes place then 4 to 1 there is a refrigerator 4 to 1 so there is a brine in brine out brine solution so here 4 to 1 we are discussing 4 to 1 during the process 4 to 1 the temperature of air increases from T4 to T1 pressure remains constant P1 equals to P4 then volume increases from V4 to V1 since it is a constant pressure process we may write down heat transfer during the process is equals to same process AMCP into dt AMCP into dt or taking M equals to 1 kg for kg of air that is Cp into dt क्या लिखेंगे 1 to 4 process T1 greater T4 smaller so हम लिख सकते हैं Cp into T1 minus T4 so heat ejected during the process Q4 to 1 is equals to Cp into T1 minus T4 समझ में आ रहा है टोटल वो हीट ट्रांसफर हो गया 1 से Q1 to 2 process हीट ट्रांसफर 0 Q2 to 3 process Cp into T2 minus T3 then Q3 to 4 heat transfer 0 Q4 to 1 is equals to Cp into T1 minus T4 then we have to find out COP मैं ऑलरेडी बोल चुका हूं कि रेफ्रिजरेटर जो कोई भी साइकिल पड़ेगा सबको हमको निकालना होगा COP कोएफिशिएंट ऑफ परफॉर्मेबिलिटी तो अमाउंट ऑफ हीट एक्सट्रैक्टेड फ्रॉम ए लोअर बॉडी डिवाइडेड बाय वर्क डन सो COP is equals to Q4 to 1 divided by Q2 to 3 minus Q4 to 1 amount of heat absorbed from the lower body divided by work done Q2 to 3 minus Q4 to 1 which is equals to already I have written that Q4 to 1 is equals to Cp into T1 minus T4 divided by Q2 to 3 Cp into T2 minus T3 minus Cp into T1 minus T4 so Cp जब मल्टीप्लाई हो ये कैंसिल हो जाएगा तो फाइनली तो COP of a well Coleman cycle or reverse Brayton cycle or reverse Joule cycle this is equals to T1 minus T4 divided by T2 minus T3 into T1 minus T4 so this is equation number 1 this can be simplified बहुत थोड़ा सा सिंपलीफाई करने के COP equals to T1 minus T4 divided by T2 minus T3 into T1 minus T4 okay तो ऊपर लाइन से हम कॉमन ले जाएंगे T4 ले जाएंगे और केवल ऊपर से हम T4 कॉमन ले जाएंगे तो कितना आ जाएगा तो COP is equals to T1 minus T4 divided by T2 minus T3 into T1 minus T4 upper line से हम जब T4 taking common upper line so T4 taking common that is T4 into T1 by T4 minus 1 नीचे लाइन से हम कॉमन ले जाएंगे T3 ये लाइन से T3 कॉमन ले जाएंगे तो T2 by T3 minus 1 minus ये से T4 कॉमन ले जाएंगे T1 by T4 minus 1 this is another equation so this is equation 2 this is equation 1 this is equation 2 upper line से हम taking करें कॉमन T4 ले जाएंगे तो T1 by T4 हो जाएगा T4 कॉमन चला गया 1 हो जाएगा ये वाला रिलेशन से T3 टेकिंग कॉमन T2 by T3 minus 1 ये वाला रिलेशन से T4 टेकिंग कॉमन T1 by T4 minus 1 समझ में आ रहा है then we know that 1 to 2 isentropic process 3 to 4 isentropic process दोनों है isentropic process for isentropic process के लिए फॉर्मूला है T2 by T1 is equal to P2 by P1 whole to the power gamma minus 1 by gamma this is equation 3 ये रिलेशन है आइसेंट्रोपिक प्रोसेस में टेंपरेचर वर्सेस प्रेशर का फॉर्मूला है T2 by T1 is equals to P2 by P1 whole to the power gamma minus 1 by gamma gamma क्या होता है एडियाबैटिक इंडेक्स that is Cp by Cv एडियाबैटिक इंडेक्स okay similarly another process है 1 to 2 है आइसेंट्रोपिक another है 3 to 4 हम भी लिख सकते हैं 3 to 4 प्रोसेस के लिए T3 by T4 is equals to P3 by P4 whole to the power gamma minus 1 by gamma. This is equation 4. This is another isentropic process. Here for the isentropic process 1 to 2 के लिए ये isentropic process that is 3 से 4 के लिए 3 से 4 के लिए दो isentropic process है. तो here क्या हो जाएगा, तो P2 is equals to P3. ये कांस्टेंट प्रेशर है ना, P2 लिखा है, P2 P2 और तो P3 P2 P3 है और P1 P4 है. समझ में आ रहा है? जब कंबाइन करेंगे वो दो इक्वेशन 3 और 4 को कंबाइन करेंगे, P2 P3 के समान है, P1 P4 के समान है. दो इक्वेशन में जो कंबाइन करेंगे, दो इक्वेशन में राइट हैंड साइड जब इक्वल होगा तो लेफ्ट हैंड साइड इज आल्सो इक्वल होगा. तो ये इक्वेशन 3 4 से P2 इक्वल्स टू P3 P1 इक्वल्स टू P4. तो हम लिख सकते हैं फ्रॉम दिस रिलेशन 3 and 4 वी में राइट डाउन T2 by T1 is equals to T3 by T4. ओके, T2 by T1 is equals to T3 by T4. समझ में आया? और हम लिख सकते हैं, और फ्रॉम दिस रिलेशन लिख सकते हैं T2 by T3 is equals to T1 by T4. Equation 5. Therefore, T2 by T3 equals to T1 by T4. Now putting this value in equation 2. Equation 2 में जब डालेंगे ये equation में क्या आ जाएगा? COP is equals to ये T1 by T4 T1 by T4 T2 इक्वल होगा. ये कॉमन आ जाएगा. ये टर्म कॉमन आ जाएगा. तो फाइनली COP of a well Coleman cycle is equals to T4 by T3 minus T4. COP of this cycle is to write down T4 by T3 minus T4. T4 क्या होता है? T4 टेम्परेचर आफ्टर आइसेंट्रोपिक ऑफ एक्सपेंशन के बाद जो टेम्परेचर ये होता है T4. T3 क्या होता है? आपका कांस्टेंट प्रेशर में आफ्टर ये 2 to 3 प्रोसेस के बाद आ रहा है 3%. 3 से 4 दो पॉइंट इंपॉर्टेंट है, टेम्परेचर एट द पॉइंट 4, टेम्परेचर एट द पॉइंट 3. समझ में आ रहा है T4? और इस इक्वेशन को हम भी लिख सकते हैं और इक्वल्स टू 1 by T3 by T4 minus 1. ये कॉमन ले लेंगे, T4 ले जाएंगे कॉमन. T4 को ले T4 नीचे T4 करेंगे. 1 by T3 by T4 minus 1 और इक्वल्स टू ये भी लिख सकते हैं 1 by T3 by T4. T3 by T4 ये है कि प्रेशर का रेशियो 1 by ये है और इक्वल्स टू P3 by P4 होल टू द पावर गामा minus 1 by गामा minus 1. और जब लिख सकते हैं दिस इज 1 by RT. दिस इज नोन एज द प्रेशर रेशियो. प्रेशर इज RT होल टू द पावर गामा minus 1 by गामा minus 1. दिस इज द फाइनल COP of this well Coleman cycle और दिस इज द रिवर्स पैटर्न साइकिल और रिवर्स जूल साइकिल. हो गया?